Okay, welcome viewers. I'm going to attach this worksheet. We're going to do the first 6 problems, which is a review of simplifying radicals and the converse of the Pythagorean theorem. So let's go ahead and start. So this is our unit on right triangles. One really important skill that you're going to need in all math classes, the phone should be away, is how to simplify radicals. Up until we learned how to simplify radicals, we would round our answers. And now that we know how to simplify radicals, we can have an exact answer. So the first problem is in blue here. We ended up with an answer of 10 divided by the square root of 3. To rationalize the denominator, we multiply by special 1, which is root 3 over root 3. That way the denominator will become a 3 because root 3 times root 3 is 3. And the numerator, we multiply 10 times root 3 and we just get 10 root 3. This is our answer because 3 does not go into 10 evenly, so we are done. Questions? Number 2. This one is a little bit more difficult because 162 is a pretty big number. So the best way to go about figuring out the largest perfect square that goes into 162 is to write down all your perfect squares. What are the possible numbers? What are the possible perfect squares that could go into 162 evenly? And when you do that, you'll find the largest one that goes in is 81. 81 times 2 is 162. And the way you do that is you just take your calculator out and you just go, all right, 162 divided by 100. Obviously that's gonna not go in evenly. But you want to try to get the largest one, so I would start with the larger numbers and move your way down. But 81 does go in evenly. 81 is a perfect square. 9 times 9 is 81. So the square root of 81, when you pull that out from under the radical, that's a 9. The 2 is still left under the radical, so it's 9 root 2. How are we doing? That was kind of a tough one in terms of simplifying radicals. People are like, no, it wasn't. Helbing, it wasn't, because you know why? You taught us well. Number 3. This one I feel like is a little bit more difficult. Well, not more difficult, but 24 is a much smaller number than 162. So it's easier we don't have to divide as many numbers in. We can start at, I guess, 16. 16 clearly doesn't go into 24 evenly. So then you try 9, you try 4. Oh, 4 goes in evenly. 4 times 6 is 24. So we're gonna break up 24 into 4 times 6. The square root of 4 is a 2. When that 2 comes out, there is a 5 waiting outside there. So it's a 5 times a 2, which makes that a 10 root 6. 6, yes, 6 is not a prime number. The phone should be away. 6 is not a prime number, but we are actually done because there are no perfect square factors that go into 6. And that's your review of simplifying radicals. Are we good? Okay, let's go to the converse of the Pythagorean theorem. Mouse, come on now. Okay, this is a little bit messy. I'm not a fan, but it's fine. So the 3 numbers that we're given to see if they form a triangle, and if so, what kind of triangle, in number 4 are 17, 29, and 32. So we are going to first figure out if it even forms a triangle. And the way we do that is we take the 2 smaller numbers, we add them up, and we see if they're greater than the third side. For number 4, the 2 smaller numbers are 17 and 29. So we check, does 17 plus 29, is that greater than 32? Yes, it is, which means it forms a triangle. Now, what kind of triangle? What kind of triangle is decided using c squared if it's greater than, less than, or equal to a squared plus b squared. C has to be the largest number. So in this case, C has to be the 32. The other 2 are A and B are interchangeable. So we put the 32 in for C. So C squared, is that greater than, less than, or equal to a squared plus b squared? So take out our calculator. What's c squared? Take out our calculator. What's a squared plus b squared? And then we compare them. In this case, c squared is less than a squared plus b squared. So that's an acute triangle. Good? Number 5. The numbers that we're asked to find if they form a triangle are 4, 5, and 7. 4 plus 5 is greater than 7, so it forms a triangle. Now, 7 has to be the C because 7 is the largest number. So c squared is that greater than, less than, or equal to a squared plus b squared. So 7 goes in for C. 7 squared is 49. Is that greater than, less than, or equal to a squared plus b squared? In this case, when we look at the numbers, c squared is greater than a squared plus b squared, so it's obtuse. So if c squared is less than a squared plus b squared, it's acute. If it's greater than, it's obtuse. And if they're equal, it's a right triangle. Does this sound familiar? Okay, the last problem we're going to look at is one where you check to see if it even forms a triangle, the two shorter sides, when you add them up to see if it's greater than the third side, and it's not. So that means it doesn't form a triangle, and it's great when that happens because we just say that doesn't form a triangle, and we're done. It's less work. Questions? Going once. Going twice. Sold.